Hi dear friends, welcome to Rajshekhar classes on applied data science with Python. This is lecture number 443. In this lecture we will try to understand relational data and featurization. Sometimes you have data that is represented in relational form. Relational data, for those of you are not studied databases, data that is stored in various tables. So let's take an example and understand relational data and how to featurize it. Again, this is also very problem specific, but I will try to explain this concept with an example. Imagine if I have tables like this. In my first table, let's call it as a customer table. What is my first table here? It is customer table. In customer table, what I have here, basically customer ID, isn't it? Customer ID, customer zip code. This stores some information about the customer. Let's keep it simple. Let's say we just have two fields in this table, or two columns which is storing some information about the customer. Let's assume we have a second table which stores, let's call it as customer viewing data. This is customer viewing data or customer viewing table. Let's assume this is e-commerce website, and the table what we are storing here is, we are storing whether a customer, given a customer ID and product ID, we are saying at which time has this customer viewed this product, at which time this customer viewed this product. Isn't it? It is simple. What happens in e-commerce? People go to website, the customer go to website and sees all the details about the product. So in this we are storing information about customers. Let's assume customer ID 2. Let's assume, let me say customer ID 2 has viewed product ID 5 at so and so time. Customer ID 2 has viewed product ID 5 and at so and so time. At so some let's assume this is the customer visiting data, isn't it? This is, what is this? This is customer visiting data, or let's assume this is customer visitation process, often called visitation data, whether a customer visited a web page or not. Let's assume we have third table. What is our third table? Purchase table. Just see, this is our, this one, what is this? This is our purchase table, isn't it? Purchase data, let's call it as purchase data. So in the purchase data, what we have here, we have the customer ID. Just check it out. This is customer ID. We have product ID. Just see, product ID, and the time at, what is this? And the time at which customer made a purchase for a given product. So we could also have fourth table. What is my fourth table? Just see, we could also have my fourth table about the product data. This table is related to product data. We could have stuff like we could have product ID and product type and information, isn't it? In the product table, we could have product ID, product type, and some other information about the product. Let's assume your data is stored in various tables like this. Such a data stored like this is said to be a relational database. So, typical relational database is relational database, Oracle, MySQL, SQL Server. These are all very, very popular databases in which data is stored in tables, and the relation, what is this? Suppose if you want to combine tables, which tables? Customer table and customer viewing table. This is my customer table. Let me say this is my customer table, this is my customer viewing table. Let it be. Suppose if I want to combine customer table and customer viewing, so you can use SQL. SQL is standard language through which you can join these two tables. You can join these two tables. Of course, you can also do it in Python itself. For example, in pandas, you can write SQL queries to do operations on tables. Data which is stored in relational database is said to be relational data. So if you have data like this, if you have data like this means if you have data in tables, then how do you featurize? That is important. That we would like to understand, isn't it? Let's take a sample task. What is our task? Let's assume task is to predict if customer would purchase product in the next 7 days. How does it work? We are given a customer ID. Let me say we are given a customer ID, product ID, and your response variable is 1 or 0. The customer would buy what does it mean? 1 means, what is the meaning of 1? 1 means what? 1 means the customer would buy the product in next 7 days. 0 means customer does not buy the product in next 7 days. Given customer ID, product ID, you need to come up with a feature vector which is let me say feature vector xi, isn't it? Your xi. What is your xi? Xi is your feature vector, and what is your yi? Yi which is buy or not buy in next 7 days. Now, how do you come up with features for this? You need some domain expertise, isn't it? Do we need some? You need some domain expertise or domain knowledge. Sometimes just common sense. One good feature here, one feature. Let me say my feature one. One good feature here, one interesting feature here. Let's call it as F1. One interesting feature F1 could be, so we know from common sense that a customer visiting a page, isn't it? Just we have table, customer visiting table, just customer viewing table. We have this particular table. Just refer this one, isn't it? Yes. What does it mean? What is a common sense? Common sense that a customer visiting a page of a given product multiple times in the last 24 hours, just you can find from this particular table, there is a high chance that he is considering to purchase the product, isn't it? If there is a customer who is visiting a page multiple times in last 24 hours, there is a high chance that he is considering to purchase the product. Look how e-commerce works. Just see how e-commerce works. If you go to Amazon.com or any of the major e-commerce websites, before you make a purchase, what you do here, suppose I am trying to buy an LG television with 50 inches, what I would do is I would go to this web page multiple times before I actually make a purchase, and I would actually look at read the reviews, look at its price, look at multiple features of a product. So one feature here could be given a customer ID, one feature could be given a customer ID and product ID. You need to come up with a feature one. number of times the customer with customer ID visited the product ID page in the last 24 hours. Another interesting feature F2, number of times the customer which given customer ID visited any product which belongs to the same type as this product ID, isn't it? Because I may not visit LG TV product exactly if I am looking for TVs. I look at all other TVs. I might be looking at Samsung TV roughly around 50 inches. So whether I visited LG TV page or any other TV page in the same TV category is also useful. Similarly, my third feature F3 could be income level, isn't it? Feature could be my income level. If there is a way to get my income level, okay, based on my spending habits, that income level I can get based on my spending habits. The fourth thing could be whether do I live, what is my zip code, because some zip codes tends to have wealthier people than other zip codes. So wealthier people tends to buy high price products. So all these are the featureizations come up with. For example, my feature F1. How do you design feature F1? What is feature F1? What is my feature? How do I design this particular feature? Just see this feature F1. Just to design this feature F1, I must see that customer viewing table, isn't it? Which I discussed, isn't it? Where is my customer viewing table? This is my customer. I must see this particular table for design my feature F1, isn't it? For designing my feature F1, I need this customer viewing table. Just that's what I'm saying here. Just see my feature and doing by group by operation. How do you know there is some group by operation? You know this from domain knowledge, or you ask somebody who worked in e-commerce from long time, who understand e-commerce very well, or you use common sense. It is either domain knowledge or common sense. Using all these data, using all these tables, you write SQL queries or Python scripts to come up with these features. So anywhere we use SQL queries on data stored in databases. Those are called relational features, and it is very domain specific. If the task changes, then feature will change. But in general, if you have data in relational table, in relational format or relational tables, SQL or any equivalent of SQL is what we use to featureize data. Of course, along with SQL, you need to have considerable amount of domain knowledge, or sometimes just common sense. Instead of SQL, you could just use Python scripts. Depends on the context. Typically, SQL is something whenever you think I have to write SQL queries to design features, you have to clearly understand that the data is probably a relational format or table, or in a relational database format. So this is how it works. Again, this is very problem specific. This is just a flavor of what is relational data. You can use SQL. You can use SQL for what? SQL for featurization. Just observe this one. If you have data in the relational format, either you can use Python script or SQL for featurization. As I told you, it is again domain specific. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.